Okay, I will give an example about the normal distribution. Before that, I have to introduce something we call the empirical rule. Okay, so what we know about the mean first. The mean is a measure of center, right? Suppose you are in a class of statistics and you took an exam, sorry, and the exam was, and your teacher posted the grades, and suppose we have, let's say we have 30 students in that class, and the average of the class was 70, right? And the standard deviation of that class was 5, right? And the teacher said that the distribution is bell-shaped. He told the whole class, the distribution is bell-shaped of your data, of your class grades, is bell-shaped. Okay? Now, you built some curiosity here, and you wanted to know how the bell shape looked like. So, what did you do first? You said, okay, let me do the bell shape. And because we know that if you have a bell shape, that means the mean is going to center the values, right? So the mean mu is going to be here, 70. You want to see your grades where they are, basically, in that distribution. What does the empirical rule says? The empirical rule says, let me write this down, mu plus minus 1 standard deviation contains about 68% of the data. In our example, what does it mean by mu plus 1 standard deviation? One plus or minus. The mu is 70, plus or minus the one standard deviation, 1 times the standard deviation, which is 5. So we have two values. The first value is going to be 65. The second value is going to be 75. So 65 is here, and 75 is here. So the empirical rule says 68% of the data are here between these two values. So 68 of the students in the class, they scored between 65 and 75. So when you look at yourself, you're going to say, oh, I am within the 68% of the class. Also, Sarah is within 68% of the class. The majority of the class scored between 65 and 75. What the empirical rule says specifically more, it says, there's the first point, basically. There's number one. Number two, it says mu plus or minus 2 standard deviation contains, guess what? About 95% of the data. 2 standard deviation. What does this mean? Mu is 70, plus or minus 2 times 2 times 5, which is 10. So what we get, 70 minus 10 is 60, 70 minus plus 10 is 80. So technically, 60 is here, 80 is here. I mean, they should be symmetric. I mean, my graph is not that good. So 80. What does this mean? It means that between these two values, we have 95% of the class scored between 60 and 80. Not only this, the empirical rule says, the last thing, it says mu plus minus 3 standard deviation contains what? 99.7 of data. So in our example, you have 70 plus minus 15. So in this case, we got 55 and 85. And if you place them here, this is 55. Again, this is not accurate. Let me make it more accurate. Okay. Oops. That's fine. Still bad. Anyway, 55 and 85. So 85 somewhere here. 99.7 of the data is within 3 standard deviation of the mean. So 99.7 of the 30 students, actually we're talking about all of them, 30 students, they scored between 55 and 85. That tells you something. That tells you that, oh, the maximum grade basically is not, it's going to be there's very low chance that there's something greater than 85, and there is very low chance to have a grade less than 55. So when you had your grade at the beginning, 66, you were like, yo, I did not like it. because you thought at the beginning that maybe the class has really high, points or grades, but you found out that, oh no, the maximum is 85. So this is the highest. This is the top student got 85. I'm 66. It's not bad. It's okay below the average, but still not too bad. This is the empirical rule. So we need to understand, what does it mean by within one standard deviation, within two standard deviation. So the mean, when we talk about mu plus minus one standard deviation, so that means we are within one standard deviation from the mean, or two standard deviation from the mean, and so on. So this is the empirical rule. This is the empirical rule. After that, I'm going to comment on something on the normal distribution, and we will be talking about the standard normal distribution.